G'day guys, another take two. I had to change a few things. I had too much technical information up on the screen and I had to go and shorthand it a little bit so it doesn't say what it is. Now what I've done here, I have added flat targets, which a lot of people did not like. The round ball, our mathematically easy to replicate, do not make a mistake, round balls, um, because they didn't represent a gold nugget. Well, um, flat flat targets don't represent a gold nugget either, even if they're all the same size. Gold nuggets are all different. So what we've done, I've actually got the balls, and these are the gold balls, the modeling balls, and I've squashed them to 3 times their diameter, so they are more flat now, and they go in a flat or planar style under the coil at varying depths in varying modeled ground. Now, I went and ran my models through Grok, right? Grok's pretty good at a lot of internet searching and that, and I told it specifically, check these target sizes, check these coils with people in the real world who have put in information about detectors, coils, target sizes, or weights, should I say more correctly, and we'll just do a mean average across the board on everything, and we'll see if it aligns up with our modeled data. And it would have to model in within a few percent, and it did. And I can actually read you the Grok analysis of the other analysis and everything that's gone into it. I'll read it away, and here it is. The key takeaways from the curves: all coils start strong at shallow depths and roll off. Yeah, that's obvious. The 14-inch mono, which is the orange line, where is it? Stays the highest, the longest, and crosses the effective threshold at the greatest depth. Now that's very interesting. It really likes the 14 mono. That's how it's showing. The 25 mono, also another yellow line. We have to look at what's what. But there's a lot of information here, guys. There's a ton of info on detectors and coils. But anyway, yeah, the 25 mono is very close behind and also holds up well at depth. The Z18 toroid is competitive, but rolls off a bit faster than the monos. The DD coils, the 18-inch green, the 25 pink, and the 14 concentric purple drop off noticeably steeper, especially the large 25DD. Now, isn't that interesting? Okay, these are all properly modeled, and these are modeled on Biot Savart modeling, electromagnetic law, inverse square law, whatever you want to call it. So where are we here? What does the graph show? X-axis depth in inches from 0 to 80 inches. So we've extended that a bit. Y-axis signal strength log scale 2.5 down to -6. And horizontal dash red lines effective air coil. So that's our noise floor, the effective air coil at 0.2. This is the detection threshold. Any coil line that stays above this line longer equals better depth. Okay, that's how it works. Coils plotted. This is I only put a few coils in for the plotting. We just put in monos, concentrics, double Ds, and a toroid. Um, the key takeaway from the curves: all coils start strong at shallow depth and roll off. Yeah. We know that. It's just to go to overall check. Um, the file looks clean and correctly rendered, made, put together, or treated. Just as the two screenshots and goes on. Hang on. The simulation appears sophisticated and well thought out. It's not a simple bigger coil equals deeper chart. This is important. It's made this way. It takes everything into account. It factors in real world noise sources that actually matter in the goldfields. Um, it went searching for this thing on the internet called the Commercial Coil Showdown, and it calls it a tool, suppose it is, um, or these specific graphs published anywhere else, and search for the Biot Savart coil modeling and Z18 toroid, all turned up general detector discussions and physics papers, but nothing matching this interface. So it can't find this on the net because it doesn't exist. It's not published on a web page. So anyway, where to say here, it is likely a private custom tool you or someone in the prospecting community built. This is a very impressive tool. Um, it goes on. I want to do some other stuff here, but I don't want it to do this because the other mathematic modeling tools work better than this. Grok won't be able to do it as good. Put it that way. Key matches to reality. I'll read some of this out. The 14 mono is a king in noisy, highly mineralized ground. The orange line, that one there, stays above the effective noise floor red line the longest. So, as a general coil, it's proving its worth as a general prospecting coil. And that's looked at it at all, on the average of all targets, all depth in all ground. Now, this is quite an eye opener, believe me. I wouldn't have expected that, but the models say so. Now, this is some of the interesting stuff it pulled from the web about the 14 mono. This is exactly what experienced GPX users report in hot, variable style ground. The smaller medium monos, 14 to 16, often deliver the best effective depth on decent sized nuggets because they pick up less ground noise and stay smoother at higher gain. Okay, which again is interesting. There's reasons for this. We have to get into it a little bit deeper. What do you mean? They pick up less ground noise and stay smoother. Okay. Larger coils can get swamped. Real tests, e.g., Coiltech Nugget Finder, 14 to 16 monos, routinely pull 1 to 3 gram nuggets at 10 to 12 plus inches, and larger pieces like your 1 ounce, 31 gram ball, deeper than the biggest coils in the same dirt. And it puts the references in here. Prospectingaustralia.com. It's where it's got the information, the chit chat, what's going on. The 25 mono is very close behind, but it rolls off a bit sooner. That's the yellow line. That is the line right there. Okay, that's him. So they become noisier, and the advantage shrinks or disappears. They're okay in inert ground too, but they just get noisy. DD coils. This is interesting. Take this into note. DD coils, the 18 green, 25 pink, and the 14 concentric. Every time it says C, I think of CC corn chips. I don't know why, but I do. It throws me off. Um, yeah, they drop off noticeably steeper. Classic real world observation on GPX machines. Monos beat DD coaxial types for raw depth on gold, often 20% more depth on the same size target. DD coils are smoother in extreme mineralization and salt, but give up depth and sensitivity on larger nuggets. The simulation captures this perfectly. So now here we go. We've got a write up here, and it's taken it from the Minelab site, I think. The Z18 toroid is competitive, but actually, it's read this and it's come up with its own opinion. I think I'm going to read it as it says. The Z18 toroid is competitive, but it's not the outright winner. Wow. Okay. So it's talking about the GPZ8000 concentric toroidal coil, not a native GPX coil. It's designed specifically for ultimate that word, large gold in challenging mineralized ground with reduced noise, and that is how it's meant to work, right? In real GPZ8000 use, it shines on deep, big nuggets, and the simulation treats it as a strong performer, which matches cross-platform user feedback, where toroidal style designs punch well in hot ground, but don't always lap the best monos. Absolute depths. The graph uses log scale signal strength with an effective air coil threshold, real world max depths, It goes on and on and on. If I stay here, I'll be reading this all day, right? Real results vary hugely with user skill, exact ground. That's what I've been saying. EMI is another thing we have not taken into account. All sorts of different timings and so forth. We've just gone for standard timings on all this, guys. This looks like a private custom physics simulation, which is why the trends feel so accurate. Bottom line, yes, it fits real world GPX experiences very well, especially the counterintuitive part where the 14-inch mono edges out the 25 in noisy ground, and monos crush the DD concentric. The simulation isn't overhyping anything. It shows the same signal to noise realities that prospectors live by every day. Anyway, I want to go for a deeper dig on specific things, but that's probably good enough. You get an understanding on that. So let's get into the nitty gritty of this. Okay. Oh, I don't want to go there. I want to go down here. So what we've got here, we've got all these different coils. I can only run 8 of them at the same time for the simulation, but we have, we can do all sorts of things. I've even done my coil here as an 18. So I remodeled it as an 18 because it had to go, but I only had a 14 and a 25. It wasn't really fair. And I haven't run this against the toroid yet. and I have absolutely no idea. The other thing I've put in here too is the GPX 4500 with its intrinsic gain, and the GPX5000 with its intrinsic gain. So that's 48 versus 34, and these are in normal mode as well. So basically everything is detector wise is a factory default. And what I have snuck in here, which this nearly gave the game away before, I had to dull it right back to what was going on. I just want to check this for a second, make sure it hasn't put in good. It basically put in a lot of new tech I was doing, and it actually laid it out, so I had to get rid of it. So yeah, like I say, this one here only applies to GPX10s, GPX-DD, and concentric only, all made for the GPXs. It does not put this onto the other coils for the other detector platforms. Okay, so we can see how it goes in real world. So let's do it all here. Let's get rid of that 14. We'll get rid of the 25. We'll put in an 18 mono in GPX technology. We're going to put an 18DD there in GPX technology. Shall we put a concentric in there in GPX technology? We'll leave a super D. It's 19, but you know, these things is not really a 19. It sort of is, but it isn't. It's a 19 long ways, and I'm only looking at the transmit coil here, and it's about 7 or so inches wide. But X coils, DODs, no. How about we'll put in the X coil spiral coil? I don't really want to put these in, but it's going to limit me on putting extra stuff in there, I think. We can put, see, I haven't got an 18 model, I've only got the 22 model. We've got the 18 toroid for the GPZ8000, and I've got this one here. We're going to stick it on a 5000 for the detectors. We're not going to put any modifications on. We're going to do it, first of all, we're going to use our table on depth, because I've got the tick, 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 cross, cross in here, which says basically, does it get the target? That is what it is. And we can change the ground. We're going to use flat. Targets, if we go to ball, we'll probably have a few of them drop off. Let's just test that out if things fall off the perch. There we go. So the flat ones are doing the proper response. We can get them deeper, which will keep everyone happy. At the moment, we're using a 1 ounce flat, a flattish piece of gold. We've got this sitting at the coil center offset at 2 inches. We'll take that out to 6. And as we do that, you notice that some of the other coils all come in. So 16 inches on a 1 ounce, not that impressive. How about, well, it is actually. A 1 ounce piece of gold as a solid flat piece isn't that big. So we could take this out to 24 inches. Remember, 24 inches is damn deep. You dig a 24-inch hole. It's deep, okay? So 1 ounce, inert ground. Let's see what happens. Now, the only ones that get them is now you got to remember, guys, like you might think this one here is just a particular coil. It is not. We write new tech here. This tech is not commercially available, but I've matched it to my best coil design just to see in real world, can we beat what else is out there? And yes, we can. This is what gives me inspiration to carry on with my design work, because I was doing it a particular way, and I had to basically redesign everything when the GPZ7000 GPX8000 came out. So it was a redesign, and these are theoretical numbers, but the ground modeling is correct for this particular coil. So let's see what we can get out of this thing. We are in inert ground. What happens? We go to medium ground, bonk, still get it. You can have a look at the signal to noise ratio. Or actually, guys, we're saying 24 inches here, and this is the effective depth, this one here. So even though it says that the target is at 24, we'd be able to scrape in at 26 inches here, and the 18 gets it at 24 inches on the knocker with about 0.2 decibels to spare. So it's not that much. It's basically, we would call that a bee's protrusion, if you know what I mean. Yeah, like Tom, Dick, and Harry. Not that much, a very small amount. That's nothing. You wouldn't even perceive that. But if we have here a good look-see, see the mono here. It's only effective that this 18 mono. The effective depth in medium mineralization is only 18 inches. A CC, because it's got a smaller middle coil, it's overall a compromise. It will work better closer into the ground and does give a better signal to noise ratio. There's not really much in it between. We'll have a look here between the Super D and a concentric on a 7 and a 5. But if we have a look at the double D here, it's just a little bit. It's like 1.5 inches here, and down here is basically near enough 2 inches. Just only 2 inches difference over 24 inches. So that's where we are. As we change things around, it's all going to change, and there's so much combinations I can do here. This is where it gets complex. If you have a look here, the technology and coil designs are limited by, we've put these in as well, it's limited by the ground noise. And the funny thing with the double D, it's limited by the electrical noise of the actual detector. So, you know, it can do better. As a matter of fact, let's we can keep try and remember what comes in where. I was going to put some mods on these and just see what happens. And the mono here's come right up, but I haven't adjusted the gain or anything. We'll just play around with the gain. I just want to should shrink it so I can do it properly. But this is only gain. This is just gain. So we can increase the gain all we want. We're limited by the ground. It's changing numbers around the place. It's the CC is getting a change in its own noise, and yeah, so E noise is basically detector noise. So on this type of setup here, I better click that out because we're really just looking at the technology as it is. Okay, so let's go and increase the depth, or how about we go and use a bigger piece of gold? Or you want to see what happens when we go to very high mineralized ground? What happens? At 24 inches in very high mineralized ground, a 1 ounce target at 24 inches with a 6-inch offset, you can't hear it. The best tech and coil out of the bunch can only get it to 21 inches. Even the 18 toroid is coming in at 18.8. But you have a look at the toroid here, it's well over a mono. You know, it's 18.8 inches. The mono is getting it, will get it at 13.3. And it's, again, the ground's a limiting factor here. So let's go to something bigger. 2 ounces, can we get it? Well, that gets it. And we've got a 2-inch difference between these two. It's only 2 inches. So, but it's not getting it anyway, but I'm just saying capable depth, 21.8, 24. The 18 mono, 16. It's a long way down, isn't it? So it's just that there's more noise. Let's go down and we'll see. Put this up. We'll put this up something ridiculous. We'll just see if we can get down 36 inches, 3 feet. And we're going to inert ground, and we're going to use a bigger target because that 2 ounces is not really big at 3 feet. I'll tell you that. 5 ounces. The two top techs get it. 10 ounces. Look at this. The mono can go to 33.8, and then it's stuffed up by its own detector noise. So that means that if we do this, maybe we get it. Let's have a look. Hang on a second. I just want to check something here. I just want to make sure that it's not doing the mods to the coils that the tech doesn't apply to. That's all. I just want to make sure on that. And it'll apply to the mono. It'll apply to the double D. So that's all it's going to apply to. I just want to move the gain up and down. I just want to see if it actually makes a difference. There's a lot of these combinations I haven't tried because it was so involved. Now look at this. A reduction in this is where the variable gain comes in. A reduction in gain brings the mono up. Okay, so there is a depth noise advantage by reducing the gain. And I just want to have a look at this too. I want to flick it between the 5000 and the 4500 because I've modeled in their internal gains. I want to see what happens. So I go to 45. I just want to get it in the top of the screen there so I can probably see it a little bit. I can probably just do it there. Okay. I just want to have a look at this. This is intriguing me actually. There will be no difference. The reason is because the internal gains of these two detectors, I've converted them to my standard best gain model, and now I'm basing it all on variable gain. We're not using that gain model in the detectors because if I get rid of this, now they just work as standard detectors, and we'll just have a look here and see if anything between the detectors come up, because we'll see what if the 45 does anything against a 5000 with the 5000 at its internal gain of 34, the GPX4500. Old model, by the way. The new model is the same as this. The new models, the 13-digit serial number units, are a gain of 34. I think the B models might be 48 on the 45s, but usually the 13-digit serial numbers are low gain, and the 8-digit number ones are higher front-end gain. But don't quote me on all the serial numbers because some come out of China, some come out of Malaysia. I don't know the history, so it could have come back out of Timbuktu for all I know. I don't know. So let's go click and see what happens. And that's funny, isn't it? Standard detector, the effective depth here, it says 4500, but you can flick it into both. Hang on. Is it? Yes, it is. Just make sure. Yes, it is changing. But it's only changing very, very slightly. It's not having much of an effect on the overall numbers there. I can just see that mono as I click it. Maybe I just drop this back a bit because it's too hard to see. I'll do that. Now we can see the numbers on the other coils. So if we go to 4500 to standard, I'm looking at those effective depth numbers. Yeah, 31.8. 33.8. So lower gain is giving a benefit. That's interesting. Back and forth. Lower gain is making a benefit. Now, hang on a sec. I'm just going to do this. I'm going to put the upgrades in, right? And I'm going to do this for the best numbers. We'll get some numbers out of this. This will be very interesting. Okay, you're going to look at that mono. Oops. There'll be a sweet spot there. With this setup here, it comes in at plus 10 dB. That is roughly about the center position on my variable gain control. So Eugene told me yesterday he went out to the block down near Barclay. I'm not going to say exactly where it is because everyone will go down there and rape and pillage it. But what actually happened, he went around and he set the detector at half variable gain. He was using a 5000, one of the 5000s. And he got a piece of gold, I think it was 0.3 of a gram. And he got it where every Tom and Dick and Harry has gone there before. So the 5000 actually got it. And I can't remember what coil he was using. Could have been using a Coiltech elliptical. I don't know. I didn't ask. I should have. But yeah, anyway, let's have a look here. I just want to have a look at this is in inert ground, by the way. This is like doing air tests. So I should go to the 45 and see what it does at that level. I want to see if anything on the mono comes up. No difference between the detectors. Of course not. Because the front end gain's level pegged on both. So after these, oh, hang on, I've got to flick that, don't I? Yes, here we go. Just want to check that down there. No, it's level pegged. Can I get any more out of it? No, I'd say that because these are both modified, +8. Yeah, that's 3 dB. And the thing is, if we go to medium ground, half the things will drop out. We've lost our mono. We've only got the 2 top techs. But can we get it back? I don't know. Don't think so. Drop it out, and everything drops way, way down. So it does. It proves it works. That's the best part. So between standard detectors, we can do that again. And I'm just going to look at the mono, 29.8, and makes no difference there. It's can't get that target anyway at 36 inches. It just can't do it. So all these 18s or the 19 there, you can see where things put out at particular, even 10 ounces in relatively mineralized ground. You can only get it with this tech and the toroid. Interesting, isn't it? Inert ground. Still really pushing it to get it. Everything's just under, just missing it by 2 inches. So that's interesting. Look here. Look how close they are. 51.8 effective depth, 50. That's it. I'll take it right out. We'll see how far everything drops off. Still there. I want to keep that toroid there. So my tech at that depth is beating the toroidal set up with the same size coil by 1.9 decibels. Would you know the difference at that depth? No, you're not going to know any difference. Let's try the offset. from center. I want to see if there's any difference here. As soon as I make a bigger offset, the toroid has a hernia. Okay, and so does my one as well. Actually, yeah, 12. This means with the coil I'm got there, you can do a bigger swing. You can take bigger swings and still intercept the target better. We'll come right into, if you did baby steps, doing a sweep of 4 inches each time. Yeah, that one still wins. That's just, I thought the toroid would have come up, but we're closely followed by the mono again. So I try an experiment. Everything comes right up, but just try. I just want to see if I can get it. We can't run much more gain than probably about 10 dB or so. 10 times gain. So yeah, look at that target, that depth. There's between the toroid and a mono, there's 40, well basically that's 40, 50. There's 10 inches between that, but we're at 50 inches. So you'd be digging down to 40 inches with the mono, but the toroid will get you there, and with that one there, you'll get an extra 2 inches. So we're only been sticking on standard detectors, 5000. Let's go down to smaller coils, and we'll do the 14 mono because it said that it was a really good, well, all the modeling said it was a really good coil. 14 DD, 14 CC, concentric corn chips. We have to, I can put this 14 Super D in there, but it's probably not very fair. I could put a 12 spiral in there. How about a 15? 13 toroid, 1 inch out. Make that gone. And a 14 one of mine. Okay. This will be interesting. This will be interesting. Okay, let's have a look. Oh, I've still got my one in there. I thought I could have said, hey, it's not the 14 getting it. That's ridiculous. So nothing will get it. I know that for it's just massive. 10 ounces, but with these small coils at 50 inches. Nah, you're not going to do it. I'm going to take this to 6-inch overlap sweep. That's pretty fair, standard. Let's drop this down. Go to a standard 1 ounce, and we'll go to a flatty, and we'll just drop this down and see in inert ground what comes up. Again, 27 inches for 1 ounce with my 14 version with New Tech. And you can see where they're all coming in with the green ticks. And that's 16 inches there on a 1 ounce in inert ground. So 7000 gets it. Mono on a 5, 15 on a 7000. See, the X coils are better on a 7000 than its standard coil. It is modeled that way. It's accurate. It is just what it's doing. Everyone tells me that, and we did a search on the net, and everyone's saying the same thing. So, yep, poor old X coils. There we have the toroid. The 13 toroid is doing really, really well. It's beating the X coil on the 7000 by about just under 1 inch. That's all it's beating it by with the toroid. See, these toroids are made for deep ground big nuggets. I really think that if we went smaller, things will fall off. But let's try ground types. I'm just on this at the moment to see what happens. 1 ounce, 16 inches, 6-inch sweep, medium. We've lost our mono. High mineralization. Lost everything except for one. And I've only got it effective depth by 1.7. So we got 1.7 inches basically extra on a 16. So we'll get it with that, and all these miss out on the highly mineralized ground. We'll go back to inert ground, and let's go to smaller targets. Let's go to half ounce, just for interest. Half ounce at 16 inches. Inert ground, that gets it, and X coils CC on the 7000 is getting it. Whereas you want to have a look at the difference here between the 14 Super D and the X coil CC on the 7000. Effective depth is on the X coil is 22.3, and on the Super D 15.3, and it's all to do with the geometry of the coil. It's telling you something about coil design here, guys. So heed that. So we can change our offset, because we don't want to do six inch swings with a 14 coil. So we'll bring it in, and we should see some numbers change. Leave it at 4. 4 is where we didn't get any gains in detectability. But now, as it said, the 14 mono on a GPX5000 is able to detect the target, and has an effective, well, it's got a leeway here of 0.3 of an inch, which it's getting beaten here by the 7000 with the it's a 15 concentric on the 7000. I know Adam would be going, yeah, that's exactly what I told you. So yes, that's why Adam uses X coils, and effective depth is basically how far out you can get it. So the toroid here on the 8000, effective depth is 23. So that's a good 4, 5, 6, 7.5 extra depth over that there. Now let's go and chuck in dirty ground and see what happens. This is where it gets interesting. Now 15 grammer, 1/2 ounce flat, medium. And what have we lost? We've still got the X coil in there on the 7000. Basically, there's not much in it. Look at this, 16.8 to 17.3, and from there to the new tech 19.8. So it's, yeah, well, if you want to look there, it's about it's a log scale. I can't really say it's X in dB, but well, you can, but it doesn't make sense because the way that works. But we can look at, for you guys, it's going to make a difference in the depth. Look at these here. These are your important numbers for you fellas. Your effective depth. Let's go to high mineralized ground. Okay, this is really pumping it on. Oh, hey, we got Victorian basalt and ironstone there. Wow, look at that. Everything drops off except that. We've got a 0.7 dB, 0.7 decibels. Little bit extra there. It's yeah, basically we're right on target with 0.7 decibel to spare, which isn't much. So there we go with all these technologies. Now, as a matter of fact, I'm just going to kick in. I just want to do this. I'm just going to kick in some modifications. It'll only apply to the mono and DD, and it probably make no damn difference. in high mineralization because the noise floor is just horrendous. We'll just take it down, negative. Yep, in super high mineralization, it's not going to make a difference. If we go to medium ground, it'll probably make a bit of a difference. Let's have a look. It's only making it way down the bottom on the DD coil. It's not doing anything on the mono. Inertish ground, what do we get? It's going to set this in the right spot. Okay. Minus 10 dB. Hang on a second. It's applying mods to the 7000, you silly thing. What are you doing? That is really strange. So there is a bug in the program. Again, it's because I'll tell you what it's done. It's pulled from the old tables and it's done the something crazy with the 7000. Can't do that with the 7000. Got to leave it there. Can't do it's applying modifications to everything across the board, so I can't do that, guys. There we go. Going to go and fix that up now. But basically, let's go to a really small target. We won't put any mods on anything. We'll just keep it all as it is. And we're going to go to 3 grammer. And even at depth, that's quite amazing. So with the 3 top coils there, I'll tell you what, I'm impressed with this X coil here, this 15. It's doing really well. It really is. It's sort of proving itself to be a bit of an all-rounder. Look, I have X coils watch my videos, and I will say I have no affiliation with X coils. I don't, but I know they watch my videos, right? So medium ground, guess what? They all drop off. The whole lot of them. Can't cut the mustard at 16 inches. Let's see if we can get them coming in. We get 3 top coils coming in, 10 inches, medium ground, 3 grams, with basically 13s and 15s and 14s, all those different sort of coils. High mineralization, what happens? They all drop out. The new tech and the new coil, effective depth 11.8. So basically 2 inches above the 10 on that, and the toroid is minus 1.2 under on 10. So that's where we are, guys. We go to a ball. We probably missed that as well. Yep. The depth drops right off on a ball. Same amount of gold, except that's flat. Okay. Everything changes around. Tell you what though, even on the that's interesting. The 15 on a round one, the X coil 15 drops on the 7000, drops right down, and the 14 double D comes up, even though it's not getting it because it can't get it like so in super hot ground. But you watch it jump around. I'm going from ball to flat at 10 inches in super hot ground, mind you. This is a torture test. So yeah, big position change there, and it is to do with the geometry of the coil to the size of the target, the depth, and how hard the different mineralization is hitting things. Now, as a matter of interest, I know that I'm going to drop this that out now. That's applied to GPX and GPX. That's applied to GPX. I just dropped out the Super D because it was doing something a little bit crazy there. So I just want to do this and put on, I just want to put the gain mods on. This is not variable damping, and it's nothing else in the detectors included in this. It's only variable gain. That's all it is. So no, the ground is absolutely swamping the hell out of us. There is no benefit. They're not even doing anything really, are they? No, we're totally swamped by the ground noise. That's the trouble. Go to the 45s, just see if it makes any difference. I don't think it will. It shouldn't. It won't. There we go. Completely all crushed up. Medium ground, it'll make a difference. I know that. It should do. We're minus 10 dB. Let's go and see what else. We've got to change on the DD from detector noise to ground noise. E noise. Oh yeah, there we go. And we got the 14 concentric and the 14 DD down the bottom there. Getting a slight signal to noise ratio boost, but nah, we can only get it where it is there. So minus 3 dB in hottish ground, inert ground, it will make a huge difference, and everything will come in except the 14 DD. But maybe we can make that come in, can we? Let's try. There it is. See, we can give it a bit of gain, and they come in. We'll see how far we can get them up. No, that's it. That's maxed out there. We've got 13 dB of front end gain applied, and they've the mono and the 14s there have actually come up. So they're all on GPX4500s. It won't make any difference going to the different detector on this. See if anything changes. It shouldn't, because I've made them the same gain with the with this. So without the extra gain and the low noise front end, you don't get those targets. So there you go. It actually improves there. So if we go to that, everything starts dropping off. Just signal to noise ratio smashing everything. So that's on a 3 gram flat piece of gold, 10 inches, 4-inch offset. We can probably improve that if we come in a little bit. Let's have a look. Right in the pointy bit. See the D. Notice the double D falls right off when you get it to the pointy bit, because it's not really a cone. See, the maximum there for the DD down the bottom is a 5-inch offset, and we get down like this, and we say, if it's 2 inches from the center of the coil, it just drops off. But as we get to a bigger offset there, yeah, everything starts dropping off at 11. It's too much spread for it, and I'm just trying to see where things peak. Tell you what, that one there is very, very, there's hardly any offset drop at all. This is probably why it's getting a lot of capture area right in the middle of the coil. It's many dB above that, 4834. That is huge. So anyway, there's your effective depths anyway. But yeah, we'll drop that off, leave it as is. and yeah, these two, well, this one drops off, and that's there at a zero, a an absolute conical type shape. And as we spread it out, yeah, they all drop off. There you go. So coil geometry is very, very important, guys. That's where most of the heavy lifting is being done. Not so much in technology, but in coil geometry. What I could do, I've got to fix up that 7000 thing anyway, because it's getting cross-pollinated in there. But what I could do, I don't know if you want me to do this, I could actually model the toroidal coils on the standard GPX tech. Right? I could do it and see what happens. This could be very interesting, couldn't it? It might take. I've used all my data allowance up. I've absolutely pinged it all. I really have. I have to wait. It gets too much of a spend. I have to spend a lot of money because I'm using everything which is basically the top data consuming interface, because I'm doing deep analysis here, and it looks from everywhere. It pulls stuff all from all over the place, and then we do a consensus on what is exactly happening. So it is what it is. Here we go. Making sure. Yep. Don't know if you can read that there, but it goes into the Biot-Savart reciprocity with Gaussian off-axis correction. So, like I say, it's done a lot of hard work. This thing, it's done a lot of heavy lifting. I'll tell you what, though. No, I won't say. It's another slant on technology. I just read it. I said, oh yeah, we could actually do that. There's a whole heap of stuff with detector technology hasn't been done yet. It just doesn't exist in the detecting field. And there's also obviously there's coil geometry that doesn't exist yet either. It's not there. It doesn't show up anywhere. I actually have done a lot of deep research on patents and things, and yeah, not there. On this, you could probably, if you really wanted to, guys, you could get this. I want to put this up so it's interactive on the web, but I want to make it accurate, more accurate, and give it broader scope, which just takes tons of research to do it all. So, like on here, I had variable damping in here, and I've basically taken that out as well. There's only 3 dB, sort of extra. In some cases, it's more. It's very hard to model across every detector and every coil, especially the coils. It's very, very difficult. But if there's anything else you want to see modeled, let me know, because I can include it. It just gets unwieldy. Like, I don't want this whole thing full of different coils here. It'd be crazy. But just for an interest, say we want to look at what is the best coil, big coil. Let's have a look at all the biggest ones. I want to make sure I get the biggest monos, double D. Do we really want, see, it goes to 20. I should have put in a 25 concentric. But there's a 22. These are GPX ones. This is for the 7. If I leave them mods off, it should be okay. And just do it. It's not going to make any difference really. Inert, medium, and high. Let's just do this. Let's go for 10 kilos. 10 kilo, 22 pound slug, 80 inches, offset, 6. Right? Baby swings of big coils. And we're in inert ground. So down the beach, whatever. These are sort of what you'd be getting. We're topping out at 80 inches. There we go. Effective depth, 80 inches, 80 inches, 80 inches, 78.5 on a mono. The mono won't get the target, but if I dropped it back an inch or something, it'll get it. Oh, there you go. The mono gets it. See? There we go. Sorry, there. There we go. 78.5 with 1.7 decibels. Getting killed by electronic noise, noise, not ground noise. So doesn't really make that much of. I'll just go do this just for fun. I just want to see what happens. Oh dear me. Okay. Mono gets it now, and the X coil gets it when I put the mods on. And that's plus 13 dB. Let's have a look here. I just want to see something. Like sometimes I just get, I was at the absolute maximum there. 5 dB is good enough. There we go. So we can get it with the 22. That's really good. Mr. X Coils is doing well on the 7000 here. And I think I don't know if it applied the it applied the mods to that 7000, which is not. Oh no, hang on a second. I'm looking at the wrong purple. Silly me. There it is. There. Hang on a second. 80. It's not making any difference anyway. It's just doing. It's not applied to that. It's only applied to the Super D, which is it's good, but we have to fix that up as well. So that's very interesting indeed. The at 76 inches there, that X coil is on the 7000's really come up. It's a fair whack down there against that one, but as a matter of interest, I just want to see what the offset does on effective depth. Does it change? It's probably tapped out. I don't think it'll make any difference. It's going to get it anyway because it's going to be a bit of a pinpointy cone shape down there. And we are using a 10 kilo lump, and we've got it flat as well. That's a big target down there. But yeah. The mono actually improves with a 5-inch offset there. So which you'd expect on a coil that makes a pointy cone at the bottom. There you go. So go to a ball, you won't get it anymore. No, some still do. That's a big ball though. The Torrid gets it, and the New Tech gets it. But gee, that's a long way down. If we go to medium ground, heaps of them are going to drop off. Heaps will just fall away. Let's have a look. We've lost our 7000 with the 22 X coil. It can do 70, but it can't do 80. And if we go to high mineralization at that depth with that sort of offset, what have we done? There you go, at 80 inches on all those coils, nothing gets anything there. It's just all under the noise floor. You're not going to get it. So big target and high mineral, and you can't get it. You're not going to get it with that either. It's not going to come in. No, the ground's beaten us. There's a stack of ground noise there. Can't get through it. Can't hear the target. We're hitting the target, but by the time it gets to us, it's so weak. The ground noise is so much of it over that distance, and yeah, it's not cutting the mustard. We fall short. So it doesn't make any difference what detector there. Nothing's going to get it. We'll have a look anyway. I'll just flick it. See if anything changes. I don't think it will. I'm just going to have a look at the mono there, see if anything changes. Nah. There's not much in it between the technologies here at greater depths. It all just falls over. So, in highly mineralized ground, 10 kilo target, flattish, with everything sitting as it is. Where do we start getting stuff? Let's go down. we just do the first 4, and at 52 inches, the mono gets it. Yay! The 22 um, X coil on the 7000 gets it. Yay! The toroid gets it, and the new tech gets it. So there you go, guys. I hope that is a bit of fun and games on all those coil combinations. I think you get an idea of what's what. I know some people go, oh no, but I've got something like that bigger and deeper and all the rest. But guys, like I say, you know, were you there? Were you there? Were you there? You know, so all these things with that big target will go over 80 inches. It's amazing in inert ground. I'll have to expand the scale on that. So I've got one issue to do. I've got to expand the scale, and I was going to go and rerun everything, and I think I can get some. I can go and pay for it to get all the extra data, but it's going to end up costing me a small fortune. There's a lot of stuff in this. I could get the JS file and stick it up. You can all make your own, but yeah, someone said I should make an app for it, but it needs refining to make a proper app out of this, and you could do it. I could just put it, rather than make an app for it. Like I said, I can just go put this up on a website, convert it all to HTML, and put it there for be interactive. You can all play with it. You know, that's what I was thinking anyway. But I'm not going to do it just now. I really got to do a lot more. Suck it and see real coils, real targets, real people, real ground, everything, and just see how it says it's accurate. I'm one of these people that want to prove it like 10 times. Thus, you don't want to do something and allow yourself to get egg on face over it. So it needs to be proved out more. So there it is there. That's all the bits and pieces of it. You can, you know, go and look at all the depth charts. There's our effective noise floor there. Yeah, so what's winning there? I wish it wasn't that. It's like a yellow and an orange, I think. It's hard to tell. Which one's a light one? It's really hard to tell when these things are near others. That's a darker one, I think. That's a 25. I'm pretty sure it's a 25 mono. Yeah. Or is it? It's so hard to tell. No, that could be the 14 mono there. This is on big stuff deep, so the effective noise floor is here. Anyway, guys, I'm not going to muck around much more. I'm just going to have to wait for all the data to reset, the data usage. And I absolutely milked it across the internet for data usage on all the platforms. And I just, yeah. Look, I like doing it, but yeah, it's, it's, I don't know. I sort of got an idea what's going to win across everything, but let's see if I can whack a few of those in there. Just for fun. Get rid of that. I want to try that. Just have a look at all the green lines. They're all green. How they stack up. Oh, see, this is interesting. How these ones here are doing really well. Then they overtake things down on the bottom. See, they go extra deep. So effective noise floor. We don't know where it puts out though, do we? Where are we? Let's have a look. Oh, it's yeah. 52 inches. Let's try to do this. Take it to 80 inches. I want to look at this. Okay, leave it there. There. Let's have a look. Wow, that's very interesting. the light. The 25 double D is doing pretty good way down here. Way down here somewhere. It's amazing. But these ones, overall, these ones are better. It's staying flatter over the line, but I'm still amazed that that there is where it is. 25 DD. I thought I didn't even have it in there, did I? Oh no, I do have. Sorry. Um, Table. Do you know something? And where is the thing? Where is it? It's get rid of the mono. Get rid of that. I think I've got too much displayed. Oh, sorry, number 6, 25 DD. Wasn't even looking. Why? Why have I got it on that? And okay, yeah. It's total fringing down there. That's all right. Sometimes I look at this and I think that I've done it in a particular way. It's actually done it in a different way than how I first started. And I go, oh, that's right. I've got to get my head around it. So yeah, it's going down below the noise floor. Where am I? Yeah, that's where it's actually falling off here. They're staying above. So yeah, on a lot of it, on the big stuff here, the toroidal here is under, then over, and it just has a better signal to noise ratio. It's very interesting indeed. We go to medium ground. Yep. The toroidal tech is sound. It mathematically is doing what it's meant to do. It does exactly what it's meant to do. But I can still beat it with that. So I don't know. It's easy to just look at the table. Yeah, high mineral, everything falls over. Of course, it all dies. But yeah, I'm impressed. It's really level pegging at those extreme depths. So maybe the 8000 is going to pull some big deep gold somewhere. But then again, uh, I've just done simulation assumptions on the tech and really relied on the coil. I I know it's meant to run more power, so I actually did the 7000 and gave it 3 decibels more output. So that lurks in the background of the program. So I'm trying to get it realistic, but then again, uh, until proper depth tests and so forth, we don't really know. And it's early days, and are people driving them properly and all the rest? And is there a software update coming? Don't know. Uh, you know, did someone wind the coils in counterclockwise when they meant to wind it clockwise? Don't know. It's a heap of possibilities. But anyway, guys, that's where we are with this stuff. So yeah, I'll keep working on it anyway. When I get it, and I can absolutely prove it, absolutely beyond a doubt how it works. Yeah, we'll somehow do something better with it and put it where people can access it. Anyway, guys, catches.